Hey everybody, this is our sixth lesson of Unit 6. It is called Solving Logarithmic Equations. It is very similar to the other types of equations that we've solved. We have solved exponential equations, most recently radical equations, absolute value equations, quite a lot of them. We've also factored, which is solving a quadratic equation. And up here at the top, I just have some info reminding you that logs are the most real-life applicable equation, at least in my opinion. They're used quite often in STEM, which is covered right here, just right now. And then here we have both of the forms. We have the log form and then its inverse exponential form. And then our steps on how to solve, very straightforward. Just like with radical equations, you got to get it by itself. So this time you're going to isolate the log part. And then once you're isolated, excuse me, you're always going to convert back to exponential form because you can't solve it with the log still in the question unless it's just typing just the log and its x value into the calculator. And then step 3 says solve for x, check your answer. These can have extraneous solutions. We are not going to look at extraneous solutions today, not within our purview of this course, but you will see them later on in upper level math. And then we're going to go kind of in a weird order, but these are kind of in a weird order, so we'll make it work. We're going to start with number 2, because number 2 is the easiest one. And number 2 says log base 10 of x equals 4. At first, we're going to try to isolate the log. This is the log. There's nothing else over here in front or behind it, so it is already isolated. Step 2 says convert to exponential form. We're going to convert back to this form right here. That will get rid of the log completely. And to do that, we start with our base. We raise it to the power of this, and that's going to be equal to the inside. So 10 to the power of 4 is going to be equal to x. And this one we happen to already have x by itself. 10 to the power of 4 is 10,000. And if you did not know that off the top of your head, no problem. You just type in the calculator. And that's the answer. Super duper easy. Let's try one that has a little more pep in its step. We're looking at number 1 now. We want to isolate the log. Here's the log. There's nothing in front of it or behind it, so it is already by itself. So we're just going to convert back to exponential form. Take our base, raise to this power, and that's going to be equal to the inside. So 3 to the power of 4 is going to be equal to the inside of 5x plus 1. And then we're just going to solve it like a normal equation. We'll simplify this exponent first. 3 to the power of 4 is 81. And then from here, we're just going to get x by itself and move that constant first. It was adding, so I would subtract it because that's the inverse. And then here I'm multiplying by 5, so I'll divide by a 5. And that gets me 16 for our answer. Out of order, go to the next page, go to the bottom. We're going to do number 8 next because that's the next one that matches what we just did. So go ahead and pause, try number 8, and then come back when you're ready to check it. Is number 8. You should have gotten -1. Our log was already isolated, so I just reverted back to exponential form. So I had 4 to the power of 1 equals 2x plus 6. And then we just solved using normal equation rules. If you're still struggling with how to solve equations, and we do have multiple pages in the beginning of our journal, starting on page 1 to help you out with that if you want to look back at it. Okay, we're going to go back to the front page again and look at number 3 and 4. We'll do 4 together, and then you can try number 3. We have 2 options when we're outside of our log. You can either be multiplying by the log or adding or subtracting by the log. If you're multiplying, obviously you would divide just like a coefficient. If you were adding or subtracting, you would get rid of this or move it by adding or subtracting it to get a 0 pair. So look at number 4 first. Normally, I will say the number is back here. So normally it would say like that and move it that way. But this time it's in the front. We know it though, it is adding. So we're not going to divide, but it's also a negative. So if we wanted to actually get this 10 to go away, if we were to do this here, that's how it would cancel out because it would add to make 0. We'll do it to both sides of the equal sign. And that would give us log base 3 of n plus 3 equals 0. And now the log is isolated, so we're going to do what we did before. We're going to raise this to the power of this equals that. So 3 to the power of 0 equals n plus 3. And then just solve from here. Any number raised to the power of 0 is 1. And then here to get 3 by its, or sorry, in by itself, we're going to move the 3. And that will end up giving me -2. Good. Try that for number 3. So go ahead and pause, try number 3, and then come back when you're ready to check it. Here is number 3. You should have gotten 84. And this one we divided because it was multiplying here. We knew it was multiplying, so there was no other sign between the two. Remember, if there's no sign there, it has to be multiplied. That's the only one that's invisible. So we divided. That got us 4 here, and our log by itself. And then we reverted back to exponential form here and solve like a normal equation. Good, let's do it again. The next one we're going to do, because it matches the format we've been doing, is number 6. This one is a little bit different though. It does have an x squared. So the only way to solve it would be not just like a normal equation. You'd have to do a multiply add chart and factor it. So we'll kind of walk this one together. Our log is already isolated. So the first thing I'm going to do is revert back to exponential form. I did that weird. Sorry, there we go. So 7 to the power of 2 equals x squared plus 3x plus 9. 7 squared is 49. And from here, I can tell I can't just do a normal equation because I have an x squared term. If I have an x squared term, I'm going to have to factor. And the way you factor something is have it set equal to 0. So I want to set this equal to 0. So to get that, I would subtract 49. I'm going to do it over here to this 9. The reason I'm subtracting from 9 is because they're both constant terms. So those are like terms. It's the only way that you can subtract from each other. And that gets us here. Now, obviously, we're going to factor. Oops, that's B. And to do that, we're going to do our multiply add chart. We multiplied it the first times the last. 1 times -40 is -40. And we're going to add to the middle. The middle term is a 3. So we're looking for a pair of numbers that multiplies to make 40 and is 3 spaces apart. It's going to be 5 and 8. If it's going to add to a positive number, the bigger number is going to be positive. So the smaller one would be negative because I have to multiply to this -40. And that would add up to be 3. And what I'm going to do now is just write out my 2 factors. I don't have to do a box or grouping or anything because I just have 1x squared. So I can just put them over here. Good. And then from here, obviously, we're just going to set each factor equal to 0 and solve. If I have x minus 5 equals 0, I would end up being x equals +5 because you would add the 5 to both sides. And then if I have x plus 8 equals 0, it's going to end up being x equals -8. Because it was +8 to make that cross out, you would subtract 8 from both sides. Sorry, from here, from both sides. Okay, good. Let's look at our last 2 here. We will try number 5 together, then you can try number 7. These have logs on both sides. And the way that we're going to go over this is actually, before we try number 5, is by looking back at our last set of notes, properties of logs at the bottom. Remember, we talked about the equality property, or the logarithmic property of equality, which is very similar to the exponential property of equality. And the logarithmic one says that if you have 2 logs with the same base equal to each other, then their insides are also equal. Meaning, if I look here, I have 2 bases that are equal to each other. They would cancel, and just the insides are equal. Very, very similar, like exactly the same as when you're doing exponential equations. If the bases are the same, the exponents are equal. From here, we'll just do normal equation rules to solve. I'm going to move x first. That's going to cancel. 2 minus 1 is 1. And then I was adding a 1. The opposite is subtract a 1. And that would give me x equals -6. Okay, now that we've seen 1, go ahead and try and see if you can do, I think it's number 5. Yeah, number 5. And see what you get. Okay, you should have gotten 3 equals -1, which is not true, obviously, because there is no number or x that we could solve for. It is going to be a no solution situation, meaning there's no number that we could plug in to this equation that would make it work, basically. Good. Same process on number 7. We have a log on each side that we'll cross out, but it is also an x squared. It's going to kind of morph these 2 questions together for number 7. So go ahead and try number 7. Hint, you will end up with 2 answers because you are going to have to factor. Okay, so pause, come back when you're ready. Is our last problem. we ended up crossing out our logs because they had the same base and were equal. And that left us with x squared plus 4x equals 5. And to be able to solve that, we couldn't use normal equation rules because we had an x squared. If we have an x squared, we're going to need to do factoring. And to factor, we have to be equal to 0. So we moved the 5. It was positive, so we subtracted. The reason that we couldn't do this right here and make that into -1x is because there's no x on this term, so they couldn't actually be combined into 1. So they got me here. I did a multiply add chart, a times c, and then add to b. The pair of numbers that multiplies to -5 adds to 4 is 5 and -1. That put me over here. If I had a number in front of x squared, I would then do the box. But I don't have to do the box because I don't have a number for x squared. And now here I'm just going to solve each one for x. So if I had x plus 5 equals 0, I would subtract 5 because I would cancel the 5. That's where I got -5 from. And then if I was doing x minus 1 equals 0, I would add a 1. And that's where I got the positive one from. And there we go. Hope this helps. Bye.